Assalamu alaikum. Welcome to this live session. I am today live with Zagard. We we haven't done a video together, have we?
No, we haven't.
First time,
Long.
first time. Good. So Zagard, what are we reacting to today?
The debate between I think Dennis Noble
Yep.
and Richard Dawkins.
Why is this debate significant, do you think?
I think the two schools of thought within the genetics or science,
They're clashing.
that are clashing.
Yeah.
And a clash between a giant and an ant, I think.
That's a good way of putting it. It's like you could, because you do archery, you could talk about a Persian bow and a little plastic bow that you get from Lidl or you get from Poundland. Yeah. Okay.
Yes.
So this is something that I've been following for a while, that Dennis Noble, Oxford professor, physiologist, evolutionist, has been challenging Richard Dawkins for quite some time. And from what I saw was Dawkins was basically evading the sort of, debate with him until now, which is very interesting. It just came out a few months ago. And a lot of people obviously are interested in this. From the outset, let's look at the two sort of opposing sides and weigh them up. I mean, people would look at Richard Dawkins and they'd say, Richard Dawkins, right? This huge scientific mind. Dennis Noble, never heard of the guy. So as someone with a background in biomedical science, what would you say? What would you say is going on here?
So, first of all, I think Richard Dawkins was announced as one of the cleverest guy alive, wasn't it, a few years ago?
Yeah.
Which I was very surprised because we know a lot more clever people. Dennis Noble is a teacher of Richard Dawkins, and he admits it in this debate himself.
Oh yes. Should we play that section?
Yeah, sure.
So let's go. What minute was it roughly?
I think it's minute 2.
Minute 2. Okay. By the way, guys, if you can hear the sound, let me know throughout the thing that the sound is fine.
Richard, we're in the chair again.
So I'm somewhat nervous. I hope I pass today.
Yes.
So I'm going to sit back and let you two take it away.
I approached this with some trepidation because Dennis Noble was actually my doctoral examiner. So,
Richard, we're in the chair again.
so I'm somewhat nervous. I hope I pass today. I would like to ask you to ignore all that was said about the selfish gene
Feel free.
earlier. To me, the argument today is about one paragraph in Dennis's excellent book, Dance to the Tune of Life, which is a wonderful book, except that it's wrong.
How the tables turn.
Okay. So right from the beginning,
Yeah.
you could see, okay, who is Dennis Noble? He clearly was a supervisor to Richard Dawkins, right? So he's not nobody. He's got to be a somebody, right? So I think that's important to establish. Do you think it's the case, Zagard, that because of his prominence, because of the God delusion and his public polemics for atheism, that people somehow see him as a defender of evolutionary science and an overall representative of the field, as if they're all homogenous and he's just there as a spokesperson? And the reality is way different in academia about where he's viewed and where other people are.
Oh, that's a deep question. I think, yes, to a certain extent, his rhetoric or his way of speaking and explaining things and his way of making evolution political, this is a thing. His many books that he has written in which evolution has been proposed as a let's say a political or even as a substitute for religion, for example. Once you start doing these type of things, a lot of people pick on that, especially people that don't understand science, but they are against religion, they are against certain political views. So therefore he became very prominent. which makes it again outside the scientific circles rather than the so he's been seen by people who are not scientists as an expert in science, you know, where there are people like Dennis Noble who are viewed by the scientists as an expert in science.
So, as someone with a strong science background as yourself, what would you say? For you, would you take him as an authority when it comes to this particular discussion?
No, absolutely not.
Okay, that's one way of putting it. Absolutely not. Okay, so what should we go to? Which minute is the next thing?
Next minute I had was 14 to 21, so that's a bit long.
No worries, 14 to 21.
But let's watch that.
Okay. Here we go.
Really complicated ways, including the ways you've just enunciated. But from an evolutionary point of view, what matters is the ones that are still here 10,000 years hence. You actually use the rather vivid image. I think you said somewhere.
Yes, 10,000 years to keep a genome in
that's
a,
right.
in a petri dish
If you were to put a genome, suppose we put Dennis's genome in a petri dish.
That's right. Yes.
And keep it going for 10,000 years. Well, it wouldn't keep going; it would decay, as you rightly say. However, the information, it could be preserved on paper. You could actually write it down in a book. You could carve the A, T, C, and G codons in granite and keep it for 10,000 years, and then in 10,000 years, type it into a sequencing machine, which we already have, and it would recreate an identical twin of Dennis Noble.
No, I don't think it would.
You don't think it would?
No, no.
Why not?
Well, it would.
Yeah. So I think we should carry on reacting to it as it's playing, because I'll get a copyright strike if we just keep playing it without speaking on it. That's the content creation thing. Firstly, the discussion is clearly about two different paradigms. You have the central dogma, the selfish gene perspective, and then you have the organism-driven evolution, or the music of life. How do you describe as the other perspective? What would you say? Like a processual perspective?
Yeah, I think that's
like a process-driven.
Yes, process-driven.
So
exactly.
it's both ways.
Yeah.
Would you say? I mean, would you sum it up as saying, Zaghad, that Dawkins is talking about something two-dimensional, and he's just saying it's just this selfish gene perspective,
one-dimensional? Yes.
Yeah, and then Dennis Noble's like, well, there's a multiverse. There's many different dimensions. There's a lot going on
to it. Yeah, it's way more complicated than that. What you're saying in the beginning of the debate, if people watch the whole debate, you can see that Dennis Noble clearly says there are certain genes that, for it, they are definitely required to be intact within the genome for the organism to function.
You can't knock those out.
You can't knock those out.
Yeah,
for example, the PRB gene.
He references a lot of papers.
Yes, and the P53 genes, because I have a background in cancer therapeutics, so I know these genes. Once you knock them out, the cells or the organism starts to die, or the cell cycles and everything around that is not controlled well enough within the cell. So definitely there are certain genes where it is what Richard Dawkins is saying. You know, you have to have those, but there is a lot of other genes where the cell starts to play around, and Dennis Noble, he starts to give the evidences, and you can then start clearly see that Richard Dawkins is out of his depth. The other thing in this particular bit is that he says that you take all the information of the DNA of an individual, and you type it up in a computer or on a stone, or carve it, and then 10,000, 20,000, whatever time later, you can then come back and rewrite or copy that gene into a cell, and you'll get an identical twin. And of Dennis Noble. And Dennis Noble then corrects him, because he now is going to lecture him and tell him there is way more required in order for it to be an identical twin than just the DNA.
Yeah.
And that, yeah.
It would need one. It would need an Excel.
Oh, of course it would. No,
Yeah.
no.
Yes. Yes. I think we need Excel.
In 10,000 years, they
Yes.
will have the technology to
You'd have
take an
to put it.
Excel.
Oh, I see. Okay, and I now therefore need to follow up on a different issue then, if I may, Richard. Yes, because you see, what it would need to be is a good self-replicator. And you won't be surprised that I disagree with you on self-replication, because I think that's a central feature. Because I think without the self-replicator, I'm not quite sure that I understand what the selfish gene idea really means. Now, let me just explain briefly why it can't be a self-replicator. The way in which that arose goes way back to the quantum mechanics pioneer, Erwin Schrödinger, who in 1942 gave lectures in the university, well, not the university, the Institute of Advanced Studies in Dublin. He published it. And what he said in that book was very insightful. It was whatever the genetic was, DNA, protein, or whatever, it would be found to be a highly accurately reproduced molecular sequence. And
So here, what's going to happen within the next few minutes is that Richard Dawkins is going to be schooled in his own theory, in his own book, about what he's talking about, basically, and why it is wrong as well. So it clearly shows that he doesn't even know
the basics of his own field.
Yeah. Oh, sorry.
No,
I think I clicked
no,
on.
no worries. You just click here and
Okay.
then pause it whenever you need to.
And he called that an aperiodic crystal. The word crystal matters there, because you see, what you say, Richard, in your books is that it replicates much as a crystal does. Now, I think that's partly true, but unfortunately not sufficiently true. Because what exactly happens, let's just go through it, and it's got to be technical for about 20 seconds or so. What actually happens is, as we all know, the double helix discovered by Watson and Crick, and Rosalind Franklin, you remember those images that were produced by, I see all the women and a few men clapping.
So
that's an important point.
This is also talking about the crystalline feature of the DNA. So they take pictures. They took pictures, and that's how they were able to describe the helical structure of the DNA structure, basically DNA molecule. Okay, so now he's going to talk about the self-replicator and why it's important to have a self-replicator in order to have an identical twin. Okay, so if you, for example, you put the genetic information of Dennis Noble into a virus, it won't reproduce an identical twin, or in a bacteria, it won't reproduce an identical twin. Why? Because that bacteria or that virus or that amoeba or whatever the organism is, or even a sheep, will use that information in a different way. You understand? So you need a self-replicator that Dennis Noble had at the start 10,000 years ago in order to produce a Dennis Noble. And this is the bit that
I'm surprised he made such a blunderous statement there. Like, to a lot of people initially when he said it, you just put all the stuff in petri dish, and 10,000 years later, voila, you're
but this again, he's oversimplifying it for people that are not scientists. You understand? And if you're driving a political movement, you have to oversimplify things.
You have to be binary.
Because and that's what's been happening over 50 years to this guy. He's been politicizing science, and because of that, he's been neglecting one of the main features of science, which is it changes. You know, there is going to be more information 20 years from now, or 100
paradigm shifts,
1,000 years from now. There's going to be more information because you're going to be viewing things from different angles. You're going to be viewing things with much more accuracy, and therefore your theories will change.
Okay, so just a question on that, right? So with Richard Dawkins, his claim to fame was the selfish gene. That's what made him famous. Okay. Now, W.D. Hamilton's ideas were popularized by him. People think it was him, but it wasn't him who came up with the theory. It was W.D. Hamilton. However, don't you think, because that book then led to The Blind Watchmaker, The God Delusion, The Greatest Show on Earth, all these things, in a way, his own credibility is challenged if the gene-centered view, the central dogma, is challenged. So do you think there's a personal think he has to defend it despite of the evidence
Yes.
against it.
Most likely. And again, yeah, this is what politicians do. This is how I view it. But also, one more thing I want to mention.
Yeah.
If people watch this debate, you need to pay attention to all the titles of Richard Dawkins' book that Dennis Noble mentions, and he gets them all wrong. The title, he calls the blind watchmaker, he calls them watchmaker blind.
Oh,
And he
right,
calls the selfish gene, he goes the gene that is selfish. You know, so he gets the
Yes. Anyway, what Rosalind was working on, very interesting fact, was not a crystal. Her work in that critical working out of the double helix was actually on the flexible thread that actually is the DNA in a cell. You can crystallize DNA. That was done much later, but not in a living cell. Otherwise, you can never read it. Now, why is the crystal metaphor accurate to some degree, but not to sufficient degree? And it's worth just going through the figures because they're very important. What happens as the double helix unwinds is a C finds its mate because it naturally likes the other one that it likes to come in and link to it. And the same applies to the T and the G and so on. So every one of them has a mate. That's fine. Now, that is a pure chemistry thing. And you could say that's almost like a crystal forming itself, because what crystals do is that the other molecules that are in solution like to, in a lock and key fashion, go into the crystal. That's all fine. So in the same kind of way, and I think this is the reason why people like Richard say it is a self-replicator and rely on the molecular biology to say that, they're quite right up to a point. Now the question...
Okay, so just before that, Zagat, I want to point out something he keeps doing, and I think it's actually a very good debate tactic, right? What Noble's doing. Noble's making a distinction between partially successful and sufficiently successful. So he's not saying to Richard Dawkins, you're wrong in what you're saying. He's saying you're only giving the partial story.
Yes.
I think that's one of the big problems here, because Richard Dawkins keeps going back to the points which Noble agrees with, but he parcels them in a way as if it's a point against him. But Noble has already incorporated those points within his larger framework.
And I think that's the task of a teacher, right? To point out to its student, you're partially right.
You're partially right.
You're missing the bigger picture.
Yeah.
And that's exactly what he's doing. He's lecturing him in this debate throughout the entire debate. So Richard Dawkins, as I said from the start as well, there are certain genes absolutely right. He's correct. You can't knock them off. Yeah, but there are few in number. Yeah. Whereas what Noble is saying, that the genome is malleable, and the organism or the cell decides which part of it needs, which part needs changing, etc. And this is the self-replication aspect of it here comes to as an importance here as well, because what Richard Dawkins is basically emphasizing on in his theory is that, we don't need that much cellular input in order to preserve DNA or not preserve, like to replicate DNA, because DNA itself can come together very
by itself,
beautifully by biochemistry. The forces of biochemistry by itself, it can do that. And Noble is pointing out, he said, okay, if you because the whole point about this is that having the genome of Noble and putting it into another organ, like a cell. And he's saying that, look, you require, in order for it to grow into a human being, you require replication, and self-replication requires high accuracy. By coming together as a biochemistry forces, you get a accuracy of 10 to the power of 4, something he mentioned. I'm not 100% sure, but you can get very low level of accuracy. The accuracy required to produce an identical twin of Dennis Noble is humongous. It's huge. And that's when the whole cell comes together and says, look, I need another version of myself. everything needs to focus on
Yeah.
on this information to be copied.
Yeah.
And this whole orchestra is then set
Yeah.
up
Yeah.
inside the cell.
Yeah. I mean, one other thing I just wanted to add, one way of explaining it, and then we could carry on playing the clip. Would you say essentially the debate between Noble and Dawkins is a debate between reductive understandings, which are very much based upon DNA as destiny, and holism, something
Yes.
which is taking everything as one?
Absolutely. Yeah. I agree with that.
All right, good.
This is
So let's go back and play.
Is up to what point? In all chemical reactions, there's an energy of formation and breakage. And from that, you know how frequently it will go wrong. It's about, in the case of the nucleotides, it's about 1 in 10,000 nucleotides. Now, you might think that's fine. If you wrote a scientific article of 10,000 words and you had only one word as a typo, you would be very pleased. But the trouble is that suffices for small viruses like coronavirus, because a mutation rate of 1 in 10,000 each time it's copied would be acceptable if you've only got, say, 10 or 20 or 30,000 as a genome length. We have got 3 billion. And the difference is around 1 million-fold. Now,
okay, that I think was a profound point. Can you just break that up a bit?
Yeah. So again, going back to his point that when Richard Dawkins said when we have your genome, we can type it up and then it's fine. We'll reproduce a twin of Dennis Noble, and he's emphasizing here. He says no, that's not all that it requires. Just the DNA, and it will be a self-replication.
Yeah.
Right. You require a proper cell, and he mentions an egg cell. You require a proper cell, that human cell that is capable of self-replicating, copying the DNA with the high level of accuracy that a human cell does. You can't just replicate it the way viruses do, and he emphasizes here, because the virus's genome is like 10, 20, 30, 40, 100, maybe maximum 100,000, maybe a bit more than that. Some viruses are DNA viruses. Their DNA is a bit larger, and most viruses, I think, are RNA viruses. So here you would have so going back to the human genome, you have billions of genes in there, and compared to 10,000, a length of 10,000 of a virus. So again, Richard Dawkins, his theory is applicable to the viruses to a certain level, not applicable to the viruses, but when it comes to humans or higher organisms, you would require a lot more information. You require a lot more science to do that, rather than just copying the gene and putting it on in a machine and then being able to produce a twin of an organism.
Absolutely.
I hope that makes sense.
No, it's total.
How accurate is DNA replication? Obviously, that first stage, which is crystal-like, and I accept the metaphor there, is accurate up to about 1 in 10 to the 4. What is the accuracy when the cell actually divides and provides 2 new cells? It's 1 in 10 to the 10. Hardly a single, that's rather like a proofreader of 10,000 books, going through 10,000 books and making sure there's not a single error in the whole 10,000 books. How is that achieved? It's utterly amazing. It's achieved by the living cell. Because what then happens as the problem of the breakages, as we might call them, in the DNA formation from the double helix when it's unwound, what then happens is a whole army of enzymes go in and literally proofread the mistakes. And I only know, that's why I say you'd have to put my genome in 10,000 years hence into a living cell to do it. Now the question is, which living cell? Because you see, that will provide all the material initially to enable it to be reproduced. So what I'm saying is that it cannot be a faithful replicator except in the presence of its vehicle, which is the living cell. So I don't think there can be a neat separation between the replicator and the vehicle.
Okay.
So
Now-
again, you know, he oversimplified it from the start. Take his genome, type it up in a machine,
Yeah.
and then you'll have a twin. And then he corrects him,
Yeah.
says, no, you need a replicator, which is the
Yeah.
cell. And then he says, oh yeah, but we will have, by that
Yeah,
time,
yeah.
we'll have a technology to have
Yeah.
that. And he corrects
It's a
him again.
disanalogy.
Yeah.
It's a disanalogy.
Yeah.
No, look, he's using terms which I think are very important to Dawkins. Like he's using a distinction between the vehicle and the replicator. He's basically saying, I'm not so happy with breaking them up so much, right? But Dawkins, his entire narrative is it's all about the replicators. The vehicles are, what's that thing he uses? Vehicles are almost hijacked by replicators, essentially, right? So these selfish replicators, the genes, these immortal coins, or these weird terms that he uses, essentially Noble is going right to the nerve cell of his entire reputation and his career based upon the selfish gene. Do you think that's why he's getting so upset when these central concepts are being challenged?
Yeah, being exposed, isn't it? His whole, it's not just challenged, it's also being exposed that he's not correct or partially correct. You know,
Yeah.
there's a bigger picture going on.
I felt he was out of his depth
Yeah.
in this debate. What do you think?
Definitely.
Yeah.
Yeah, he's out of his depth because Dennis Noble mentions all the literature, scientific literature,
And
that
Dawkins
he's
is not.
quoting. Dawkins, no, he's not.
His
He's
sound
not,
bites.
yes,
How can all these guys be wrong? You know, using all this
yes,
consensus.
and most the biggest scientific paper he can mention is his book, which is not a scientific
It's not.
paper.
And the thing is, he's trying to give this idea that they all agree.
Yeah,
Firstly, that's not true because Noble's been giving evidence going back a long time. However, it's also the case that so what if everybody agrees? There can be a paper which challenges the agreed consensus.
yes.
But the thing is, there is no agreed consensus because there is a live discussion going on. Now, we went up to 21, from 14 to 21. What's the next part we should play?
So the next part is regarding evolution and then the gene pool. I think that he's mentioning it's 41 to 44. So we're going right close to the end of the debate.
Was a Lamarckian.
Okay, I do think this is actually quite misleading.
Those have been experiments are simply beautiful. Just go online and ask to look at extracellular vesicles made evident by labeling molecules fluorescently. So they literally glow green, yellow, red, or whatever it might be. It enables you to know this is this particular RNA, this is this particular DNA, and so on. And that escapes the limits of light microscopy. You can actually resolve down to very tiny particles indeed. They're called extracellular vesicles. Those have been shown experimentally to be passed to the germline. That's how the RNAs and DNAs, the new RNAs and DNAs, get to the germline. So I think that if he was alive today, I think Charles Darwin would be praising and cheering the discovery of extracellular vesicles. They are his gemmules, and they carry out the function that Darwin proposed. Now, why did he spend the last 20 years of his life collaborating with George Romanes? Is because he actually thought this must be right.
Okay, so now we're getting into territory. We're just going to go back and play it, but now we're getting into territories where I think a lot of people would be really surprised at the nuance. It's not the case where Lamarck was completely blown out of the water by Darwin. It's a case where later on in life, Darwin was revisiting certain ideas of Lamarck and seeing if they can work. And it's so interesting that Richard Dawkins, being a supposed Darwinian, is not as open-minded about Lamarckism as Darwin was.
Yeah,
It's quite ironic, no?
it is, and it shows that there was a debate between them, ongoing, until the end of their lives.
Yeah,
and to be so close-minded by, like Richard Dawkins about these debates. I'm surprised. And to call yourself a scientist, and not accepting that science can change, and it can change your, the paradigm shift, it can change, the theories change, and because of that, it makes science beautiful. As a Muslim, I love science. I'm not ashamed to say that, but and it's not going against what we believe in a certain sense. But once we start making it dogmatic, and once we start making it, these what Richard Dawkins is doing, categorical statements, then obviously it becomes very ugly and
and it's not really science anymore.
Yeah, it's not science anymore, exactly.
So I don't think it's trivial that Darwin was a Lamarckian.
Okay, I do think this is actually quite misleading. What Darwin's gemmules were supposed to be about was investigating the current state of the body and passing it on to the next generation. So the gemmules were going all around the body, and they were
that's right.
detecting changes in the body. The sort of classic Lamarckian examples, like the blacksmith's arms getting muscular and the giraffe's neck stretching and things like that. Lamarck thought that those were inherited. Darwin, in his later years, thought they were too. And Darwin's gemmules were going around the body in the bloodstream and picking up information about the current state of the body, the modified state of the body, the acquired state of the body, and going to the germline, going to the gonads, and imprinting the information into the germline. Now, that is a very radical idea.
It's precisely what the extracellular vesicles are doing.
Well, yes, but they're not. It's nothing to do with blacksmith's arms. It's
okay. So clearly, I think he's hit a nerve, because Dawkins had to admit that Darwin was playing around with Lamarckian ideas near the end of his life. Well, the last maybe decade or so.
Yeah. So here, one thing that Dennis Noble emphasized on this, talks about a bit earlier, that I didn't. Basically we didn't listen to yet, or it's earlier before this bit, is that the vesicles, the vesicles within the extracellular vesicles coming into the cell, giving it information. It could be DNA, RNA that he mentions, or bringing in other substances to the cell, giving it information. So the debate up to this point was that the cells are capable of shifting around the genome, or deleting bits of it, or like removing bits of it and adding bits to it. They're capable of doing that. The cell is capable of doing that. I think adding bits to it, not deleting. I'm not 100% sure. I don't remember the debate 100%, but not to make a mistake on it. So he says that these vesicles, they come and they bring new information. They can be added, and then that can end up into the germline genome. And then Richard Dawkins then says, okay, but this is what the Lamarckian principle, and Dennis Noble then says, yes, that's exactly what the Darwin later on in his life said. These are the gemmules. And Richard Dawkins is explaining it, although they're slightly different concepts because the vesicles, they're acting on the cellular level. They're not actually going to the bloodstreams and etc., but they're acting on the cellular level. But the biology back then was a lot simpler, primitive than what it is now. So so the explanation is a lot simpler.
I mean, it's kind of would you say it's similar to us using the word random mutations rather than random variations in the past, because obviously we didn't know about genetics and stuff.
So they may be doing something. If you're right about the immune system, now you seem to be suggesting that what happens is that when the immune system reacts to an infection like COVID, and we become immune to it, that immunity gets passed on.
No, I deliberately said we're not yet sure about that.
I know you did, and I'm glad you said that.
What we are sure about is that other things are passed on. Metabolic disorders are passed on. and sexual preference are passed on.
Well,
Now,
sexual,
again, I've got the
sexual
references.
preferences in what way passed on?
It's passed on in planarians, and that's been demonstrated. Again, all of these references, I'm very happy for people to email me and ask for them, but that's been...
You know, that's just, sorry, before we carry on, Zagar, one thing I noticed, right? It just seems like he is ready at the drop of a hat to provide a reference to a recent scientific paper, and Dawkins is caught off guard. Many, clearly, he's just out of his depth. He's like, okay, where is this? Okay, here it is.
Yes.
And Dawkins is like,
yeah. And here again, he mentions, maybe immune responses are passed on, and he is being corrected. No, it's not the immune responses. We are not sure.
And we never said that.
We still need to do research about that.
Yeah.
And he's being corrected again and saying exactly what. And the availability of the research paper, that's what makes it so much more significant from Dennis Noble's perspective.
Been shown very recently by Toker and his collaborators in work in Israel, and I think that is actually a 2021 reference.
And how many generations?
Okay. So Zagar, I just wanted to add something before you play, right? Look, what it basically is, right? It's like a discussion where Noble is making a point, and Dawkins is like, "Where do you get that from?" I got it from a paper, right? And the paper they came up with so and so. Rather than acknowledging, oh, okay, so you have a reference for what you're talking about, he goes straight to, well, how many generations? Well, who cares, right? Who cares? The point is, he is making a reference to a concept which a reference to some experimentation which you weren't aware of, and automatically you questioned it. He gives you a reference. Rather than acknowledging, okay, that happened, you move on to ask a question about that experiment. Well, here's the problem. Firstly, you've been caught off guard. You can't hide by asking another question. Secondly, he said, how many generations? In this discussion, when the lady asks him, or I think Noble asks him, how many generations do you need for it to be in the germline, or for you to accept that it's significant, significant, right?
Yeah.
He doesn't have an answer. So he doesn't even know, according to himself, what criteria, what threshold is required for generations to be a certain number for him to come to a decision. So I just found the way that he addressed him being caught off guard was a classic diversion. He didn't acknowledge, wait a minute, you've given me a reference to something which I challenged you on.
Yeah, but exactly. So he challenges it at the beginning, and now he's saying, let me change my question. Let me change my challenge, saying how many generations. Understand? Challenging it first that it is impossible for it to happen. And then saying, okay, if it happens, now let's agree. Let's agree. Okay, it does happen. How many generations does it stay within the organisms or the progeny? So this is the bit that you just described is going to come up.
Well, what they're showing, come back to the point I made about temporary and permanent, because you see, temporary is actually an advantage if you don't yet know from an evolutionary perspective whether the change is valuable or not.
So
I think it's great, you see, that epigenetic changes and temporary alterations of the germline are not necessarily passed on through many, many thousands of generations, because if the change in the environment is really temporary, you don't want a permanent response. So I can see
that makes the organism so much more versatile and so much more robust and rough and tough, compared to having a variation, and then due to natural selection the whole generation passes. So it can happen, it can. There is a possibility theoretically, but this is way more plausible. For a change to be temporarily in the genome of the next generation, if that external environmental pressure is changed, that change is also lost then down the further generations, right? So this is what the beautiful response when he says how many generations it stays, because he's coming now towards saying, okay, it's not going into the genetic the gene pool, the evolutionary gene pool, which has to be robust for millions of years. It has to stay like that for millions of years. So, sorry, can I
evolutionary logic of doing it in that kind of way. You keep it soft until it needs to become hard, and then you let it become hard. You let it then become assimilated into the genome.
Well, that's fine. I mean, that's coming back to the Waddington effect in a way.
To some extent,
Yeah.
Richard. Yes, I think.
Again, okay, look what's happened. Look what's happened. Let's go back, right? Essentially, he's saying that's impossible. Here's a paper. What's the detail here? Here's the detail. Well, it's kind of similar to this. You just look, acknowledge you've been refuted. Yeah, please. Mr. Dawkins, just acknowledge you've been refuted. You said something's impossible. You were given a reference. You're caught off guard. You asked for a detail in a questioning way. You're given a sufficient answer. And then he said, well, it's kind of like this.
Yeah.
Well, clearly, you don't really understand that in front of a live audience, you've just been humiliated, right? I mean, look, a lot of people, this is why I wanted you here, Zagad, right? A lot of people, they don't understand the significance of what just happened there. They don't understand.
This again, because he is a top scientist to layman people.
Yeah.
He's not,
and he's confident.
Yeah,
he's confident when he's wrong. Let's go back to this point.
This is why I said that Waddington was badly ignored. Yes.
Or sometimes called the Baldwin effect.
Sometimes called that. Yes. But I think what's happened today is that
But he's not making any points. He's not making any points. He's like, it's kind of similar to the Waddington effect, kind of similar to the Baldwin effect. Yeah, but hang on a minute. You just challenged him. He gave you a reference. You challenged him again. He gave you a reference. And now you're like, well, what you're describing is kind of like the Baldwin effect or the Waddington effect. Yeah, but you're supposed to be pushing back. And he's even with his body language, he's just kind of like, I want this debate to be over now. And this is near the end anyway.
Yes, a few minutes left.
We actually now know the precise mechanisms by which it can happen. We know the molecular biology of it. We know the cellular biology of it. So what I'm saying is it's time for evolutionary biology to catch up.
So exactly. So he's mentioning these two effects, the Warrington and Baldwin effect, and he's kind of like brushing it, and he's saying, no, yes, it is that. But now we also know the mechanisms by which it happens, you know, and that's
Previously, they knew the phenomena, but they didn't know the mechanism. Now he's saying that. So in a way, he's learning.
Yes,
he's a student learning live. He's learning from his supervisor.
In this debate.
Yes.
I mean, if I may ask, in that case, how long would it need?
She's trying to save his reputation. She knows. Wait a minute, he's looking really bad.
To be. I mean, you've asked a few times. I'm really taken by this sort of temporal thing. How long would it need to be to have an effect?
This is
okay. Wait. Brothers and sisters, what you're about to see right now is the most classic own goal you're gonna see academically, right? So let's just go back to her question, just a few seconds, and let's see. Wait, I'm not playing it. There we go. This is so beautiful. She's there to help him out. But she actually lays him up, lays a trap for him.
No, but she mentions that she understands, and it's more natural or logical to understand what Dennis Noble is saying than what you're saying. So how long do you need for it to be?
Now she's getting refuted by the moderator. Yeah.
How long would it need to be to have an effect, do you think?
In order to be evolutionarily interesting, then it needs to be something that we see as a change in the gene pool, and change in the gene pool would be. I mean, I can't put an actual number of generations.
Wait a minute. Wait. Let's just. So you want to challenge based upon how many generations, but you don't have a number in your head.
Yes, don't.
And for me, that was just ridiculous.
And I think Dennis Noble was
smelling blood.
No, he was very, very polite by not asking this question from him. He was explaining the science. He was lecturing him. He was teaching him in this debate, but not asking him these questions that would embarrass him. And the moderator
embarrassed him. Yeah, that was funny. That was so bad.
On it, but it's not a proper Darwinian change if it's just For example, there's evidence that starvation effects
Yes, I was going to ask about that next. Yes,
and these are, as it were, I mean, epigenetic effects are changes in as the embryo develops, changes in the expression of genes in different parts of the body. So in liver cells, certain genes are turned on. In kidney cells, other genes are turned on. Muscle cells, other genes are turned on. Those are epigenetic effects. Now, there is some evidence that those epigenetic changes can be inherited into the next generation.
Okay. Now, what's interesting is he's making a point that this is important. He's making a point which Dennis Noble and him already agree on. That's the first point. The second point is him bringing up that point is not really addressing the question he's being asked. So he's kind of like, I almost find Richard Dawkins sometimes just starts speaking to fill up the gaps in his knowledge. He goes back to things that they already agree upon.
Yeah.
Like what in...
He does know.
Yeah, he does know. What exactly did he say right now that Dennis Noble would disagree with? In fact, he's talking about those epigenetic changes, which they all agree about.
Yeah.
So sometimes don't you just feel he's just literally buying time?
Yeah. Yes. And you would see if we're gonna play it a bit more, Dennis Noble comes up with an answer to how long. So Dennis Noble is going to answer the moderator's question to Richard Dawkins, yeah, that he himself could not answer, and he will answer it.
Yeah.
This is
In a brilliant way.
Yeah.
And possibly the grandchild generation. That's not a proper gene pool change.
Yeah, I think Richard is right on that. But what we would need to do is to look at the effects after billions of years. And that's exactly what the Human Genome Project did in its Nature paper of 2001. Remember, I referred to figure 42 of that paper.
Bro, this was such a smackdown.
Yeah. So he answered this question.
He answered his question, and look, the guy is so brilliant. He will go back to a figure in a paper 20 years ago. You know, he was ready for this.
You see there the evidence that those genomes were changed by moving great chunks around in the genome. It's not time, I guess, to go through the detail of that.
Yeah,
but
unfortunately
that's fairly clear evidence that it must have happened during evolutionary timescale.
Fascinating.
He's completely... he's completely caught off guard.
Yes.
And you know what I find really interesting, right? These papers that he's referring to, these studies, because remember, now this is important, right? So God, you can help us out because you come from that background. If I'm having a debate with you and we're having a debate about is Lamarck relevant, if I pull up a popular book from all these evolution books, right? You're going to say, where's the paper? You're not going to say, the extended phenotype or the blind watchmaker. These are not referenced.
They are not papers.
They're not papers. And what you
peer-reviewed papers.
Peer-reviewed,
this is
It's almost. I'll tell you what. You know those Westerners where Western films where the guy comes up with the two guns and he's wearing the cowboy hat. It feels like Dawkins is blank. He's short on ammo. He doesn't have reference. He doesn't have things ready to tell him.
Fist to a gunfight.
Yeah. He's brought a spoon to a gunfight.
Yeah. But But here, Dennis Noble answers the question, and also final blow to him, because he kept emphasizing that it requires a large amount of time for it to become an evolutionary interesting or significant. And then Dennis Noble says, yes, you require millions of or billions of years, and we can see it from that figure in this paper, where these genome shifts have happened. You know, over this amount of time.
And his expression says it all.
Yeah,
right there. You can
beaten, poor guy.
It's obviously also important to say that increasingly with modern technologies, people are starting to look at sort of the genomes of other humanoid species and looking into the past to sort of get more information on perhaps what our more recent ancestors look like. And it might be quite interesting to sort of see whether or not that those pieces of data can add to this conversation in due course.
What bothers me is Dennis is saying Lamarck is back, because in order for Lamarck to be back, it seems to me we would need to have something.
Okay, brothers and sisters, I just want you to go back to something, right? Get rid of Lamarck. Don't even call him Lamarck. let's look at concepts. There's a concept which Richard Dawkins says is impossible. Dennis Noble gives the reference for the concept, game over. Now he's going back to an earlier point that he made, which is he used the word Lamarck, and you're going to see the definitions obviously get a bit hazy because the Noble may have a different definition to Richard Dawkins. The question here is, why are you going back to a point that was made before when you've just had some profound teaching, free tuition right now? Like, acknowledge the points you were refuted on.
He wants to have the last word, isn't it?
Yeah, he wants to, again, go back to a point which is not really that relevant. It doesn't matter whether you call it, look, would you agree with me, Zagat? You can call it Lamarck or neo-Lamarckism or call it something else. It's the concept which is important. It doesn't matter if you want to say, what he's basically saying is, why are you calling it Lamarckian? I don't think we should call it Lamarckian. Well, it doesn't matter. Because we agree with the phenomena, right?
Yeah. It's the science that is important.
Yeah, exactly. That it's just such a silly point.
Yeah.
More like the blacksmith's arms effect, where an adaptation, and I mean, there are plenty of adaptations that happen in lifetime. Your muscles develop when you use them. It would be wonderful, maybe on some other planet. It happens that when your muscles develop, when you get a suntan, when you all sorts of adaptive changes like that get inherited. And that's what Lamarck was suggesting. And I think to say that Lamarck is back is going to give a misleading impression, because people will think you're saying that something like the giraffe effect, the blacksmith's arm.
Okay, so here's a point. Here's a point I want you to give me your thoughts. Dawkins is saying, by you saying Lamarck is back, it's misleading, because Lamarck is not just these experiments that you've proven to me now. Lamarck is these other concepts which are unproven. Say he's correct. It doesn't matter, because those things that Noble showed, which are true, are part of Lamarckism. So at least Lamarck is partially back.
Yes.
Right. Secondly, he's basically saying the other concepts in Lamarck's ideas haven't been proven. It doesn't matter. It doesn't matter if even Lamarck's wrong. The point is, these particular points that you said, that these dogmatic ideas that you have about the selfish gene, he just showed how that's wrong.
Yes.
Acknowledge that. Don't go back to something which is like, it sounds relevant what he's saying, but it's actually a diversion tactic.
People need to understand that both Lamarck and Darwin in their time, biology was very primitive.
Yeah.
It wasn't as advanced as it is now.
Yeah.
So to nitpick,
on
saying that one person saying, okay, I took this from the Lamarckian idea, but we have further developed it, and we now know the processes, and we now know exactly how it happens, but it was partially explained 100 or 200 years ago by someone else, and you're saying no, but that someone else also said X, Y, and Z, and that is completely wrong. So therefore this must be wrong. That doesn't matter, because part of his answer was correct.
I mean, look, another way of putting it is, you're reading a comic book, right? Spider-Man or something, right? It mentions Big Bang, and it mentions Einstein, and it mentions quantum mechanics, and then it mentions flying venom or whatever. Right? Yeah, but those concepts are true. It doesn't matter if the rest of the magazine's nonsense. And of course, we're not saying it's nonsense, the rest of Lamarck's ideas.
I think what I'd be very precise, it is that the inheritance of use and disuse is now evident. That's the way I would put it.
Well,
yes.
Is it? I mean, you're not going to go out and say that adaptation, as we see it in the field, as animals develop camouflage, as animals develop stronger bones as they use them, stronger muscles as they use them, that would be a proper Lamarckian effect. That would be a real adaptive change as a consequence of use and disuse.
When we know that the RNAs that communicate all of that can be transmitted to the germline.
Oh my gosh.
So
Look, what's the significance?
Look at his face at the end.
What's the significance? I mean, just she's chilling, he's vexed. What's going on? Tell us what just happened there.
So again, he does by saying that the Lamarckian idea of adaptation not being applicable, in this case, whereas again, Dennis Noble goes back to a paper saying we now know that the RNA goes and the DNA goes, and information is fed to the genome, by the cell, You know, we know that, but the processes by which it happens, we know that how it happens now.
Yeah.
So it is significant, and he's saying, and he's correcting him again. He says, look, yes, changing of camouflage, for example, these things might not be taken, but even that, for example, camouflage, you know, one organism can develop it at a certain point, and it can transfer it into its genome, you know, and that's exactly what Dennis Noble is saying, having it soft copy, you know, in order to see if it's actually beneficial in the next few generations or not. If it is, then let's keep it.
Yeah.
You know, and this is exactly what he's saying now, and he goes back to the concepts. I think
we've got part of the evidence that have obviously, I mean, what I would want to say on this is open field for experimentation in the future. That's what we need. We need to be open to those possibilities.
On that delight,
who's being dogmatic now?
Exactly. Who's closing it? Who's closing the scientific field of biology?
Yeah.
And closing it off to any new idea.
Full note.
This is exactly.
Please, can we take a moment to appreciate the civility and eloquence with which these two gentlemen have debated and disagreed this moment?
Dawkins
Sign my book, Dennis.
Oh my gosh, look at that. Will you sign my-
Oh, they're just talking about smiling. Oh, isn't that cute? He just got refuted, and he's talking about, he's such a charmer. He's like, oh, son. All right, would you put it this way, yeah? Like you just, for example, you picked me up on the way here, right?
Yeah.
Imagine you're a plumber, and I called you over to do some plumbing, right? You turn up to my house with a toolbox, and all it has is one screwdriver. Or you turn up to my house with a toolbox and it has a screwdriver, it has a drill, it has a hammer, it has a measuring thing, it has so you get a toolbox with one tool and a toolbox with loads of tools. And what Dennis Noble is basically saying is, why not epistemically open your mind to all these possibilities based upon this evidence? And Richard Dawkins is going back to the selfish gene, the central dogma, you know, the modern synthesis.
Yes.
Don't you find it's literally the case of someone's being really open-minded and someone's being narrow-minded, maybe perhaps because their entire career has been based upon the selfish gene idea?
He's doing exactly what the church did. Exactly. And this is what they're fighting. This is, I swear, he's doing exactly what the church did to the scientific fields in Europe.
Yes.
He's doing it now again by saying this stuff.
Absolutely.
And disagreeing with this.
On that point, we can end the stream. Jazakallah khair for your thing. Any last message you want to give about this particular debate? Anyone that's going to be watching it?
I don't know what to say. If you're watching it, look into the papers that Dennis Noble is mentioning. I read, I think, 1 or 2 books of Richard Dawkins. I never read it as a scientific. Never.
Fiction.
Wallahi is a fiction thing.
Especially The Blind Watchmaker.
Yeah.
Blind Watchmaker is not based on scientific evidence. The Blind Watchmaker is theory of just those stories. This thing could have evolved using this.
Yeah.
Now, the greatest show on earth, he gives scientific references. We can see, okay, he's trying to make scientific points. But things like The Blind Watchmaker, things like the God Delusion, those are not scientifically credible.
Yeah, they're not.
Yeah.
I don't think they are. And I read The Greatest Show on Earth a few years ago, a long time ago now. And one of the things that I found in there, he gives a very strong argument regarding the wolf evolving into a dog.
Yeah.
And then I was impressed by it. Wallahi, back then I was impressed by it. So I did a bit more research, and I found out that they are the same species. The wolf and just, you know, they go through adaptations, but they are not a different species. You haven't created a different species, which evolution clearly states. They have to go into a different, so they can breed again and all that.
And it has to be based on, you see, even in the book.
So it's a lot of deception.
It is. And the thing is, even in The Greatest Show on Earth and the rest of the argument, he'll give evidence through homology. He'll give evidence to comparisons of genomes and anatomy. But that doesn't give an iota of evidence of natural selection making the changes. Because essentially, Darwin's theory is not a theory of similarity. Carl Linnaeus told us things are similar. Darwin's theory is the theory of transformation based upon the mechanism of natural selection working on random mutations. That's the theory. And there's zero evidence he even attempts to show between how does this organism evolve into that organism? All he's doing is using homology arguments. He's not showing how natural selection did that. Darwin's main idea was natural selection, wasn't it?
Yeah.
And he never talks about, he doesn't provide evidence for it. He just he just gives you these blanket statements. Natural selection did it.
Yeah. So if you watch the debate, try to look up the papers as well. If you're into scientific fields, if you're a student of science, inshallah, that would give more depth.
Absolutely, absolutely. All right, Zaghad. Jazakallah khair. It's fun refuting Dawkins with you. Inshallah, we're going to do something in the future.
Inshallah.
All right, for everybody watching, Assalamu alaikum wa rahmatullah.